Our next thing to address in our lab is going to be the different characteristics of a river and a river channel. There's many different stages of a river. As you know, water kind of takes its easiest path, and it's going to go, wherever it's lowest, right? Water wants to find the lowest spot. If you think about if your basement's ever filled up with water, it's always going to pool in the lowest spots first. And that's true for a river that is flowing down from a high spot to a low spot as well. It's going to follow the valley. So water is going to flow through land where there's already a valley that's cut out. It's taking its easiest path, and it's going to kind of be fast moving. So fast moving rivers are newer rivers, and it's going to follow a relatively straight path. As a river gets older and older and older, we go from just this V-shaped valley here to a wider valley. And the river is going to go ahead and start cutting into the land more and more. And it's going to be cutting down into the land more and more. And it's working down towards the water table. And as it's cutting into the valley and cutting down into the land, it's going to begin to what we call meander, which means it's going to work back and forth and back and forth and back and forth. You're also going to see that as it meanders, no longer is it just eroding all of the time. It is eroding and it's depositing as well. In a meander, it is going to erode on the outside of that bank where the water is flowing the fastest. On the inside of it, right here, we are going to see some deposition. So that means that it's going to deposit whatever particles, sand, gravel, silt, clay, that it might be carrying. So we have erosion and deposition happening in a relatively old river, and the floodplain is going to be widened out by quite a bit. In a very old river, we're going to see some much larger meanders. We're going to see a much larger floodplain. We're going to see some well-developed marsh areas as well, and we're going to see that river has really slowed down. It's got a nice riverbed. It's got a nice sandy and silty riverbed versus a rockier riverbed, and that floodplain is going to be, again, very well developed. So again, kind of looking at just the general flow and plan of a river. When there's a gentler slope, we're going to see that the river is going to move relatively slowly. As those slopes get steeper, the river is going to move faster. It's going to be able to then cut into the ground or surface that it is flowing over a lot easier. We might begin to see these meanders. In these meanders, we're going to see that there's going to be that deposition site and also that cut bank site where erosion is happening. So water is moving much faster on the outside than it is on the inside. We're going to see erosion happening out here and deposition happening inside of here. And then you might be able to look at the cross section of a river as well. And here's some things that we might see. A curved channel is going to look like this. You can imagine that this is where the erosion is happening. This is where land is getting cut into. And then this is where deposition is happening. This is where sediment is being laid. In a straight channel, it looks pretty much uniform all the way across. There's no one place where it's faster flow and slower flow. There's no site of deposition, and there's no site of erosion. It's pretty much uniform all the way across. In a braided channel, typically slower moving channels where the amount of water that flows through them changes annually or seasonally, and they're going to be relatively shallow, but again, pretty much uniform all the way across. Again, this is just going to show that during high flows, that's when a river is going to be most effective at eroding. That's because there's more water there to carry more sediment. Water is moving faster, which means that it has more power to erode. and that means it's going to make that deeper cut bank. So over time, if this is what the riverbed would have looked like if there's a higher flow, after it scours it out, it picks up all that sediment, it would bring it here and erode it down to a deeper level. And once it began to slow down again, we would see more and more deposition. We would see more sediment build up on that inside deposition bank. So again, we see an older river. We've got a relatively wide floodplain. It's pretty well developed and cut down into its riverbed, and it's got some relatively large meanders. And then here is what we've got our deposition bank, or what we call a point bar. Point bars are deposited on the inside banks and bends along a channel due to lower velocities and increased flow friction. So water is moving slower at this point in a meander than it is during the straight points or out here in the outside of that meander. So we're going to see some nice kind of sandy beaches here and some nice deposition of sediments. So you could imagine that there's going to be different amounts of sediment deposited in rivers based on how much it meanders. For a river that doesn't have very large meanders, this might be a newer river, we are going to see smaller deposition banks and smaller cut banks. But on the other side, when these meanders are much larger, we're going to see larger deposition banks and also larger cut banks here. Braided channels we kind of talked about. Braided channels are beautiful. We see them in places where there is a large fluctuation in seasonal or annual flow. Typically we see this in the drier parts of the country, or we might see it in places like the Arctic region. So this is very common in, let's say, Alaska. And it's because of the amount of snow melt and then during the spring thaw, and then it dries up. We could also see this in a desert. And then again, like we were talking about, there's a certain capacity that rivers have to carry sediment. And that capacity to carry sediment is going to be based on how fast that river is moving. So the things that we would talk about is how much can be suspended, how much is the river itself actually carrying, and then how much is actually moving across the bed of the river. So there's a couple of different types of particle movement. There's a suspended load, stuff that's actually suspended or floating in the water itself, and then there's the bed load, the stuff that's either rolling across the bottom or just kind of shifting along its way. If you went into a stream and were to pick out some rocks, you would find that most of them are really well eroded. They have nice round surfaces, and it's because of this movement of particles through the water. So you can have a suspended load or a bed load. We could also have saltation, which is the bouncing of particles. And they're kind of getting picked up and rolled around, if you can imagine that. But all of these things, the river's ability to do this is based on its flow and flow rate. So one of the things you're going to be looking for in your lab is to determine how different flow rates affect different amounts of sediment that can be carried and the size of sediment that might be carried. Again, these are just some different diagrams showing you how effective a river may be at transferring that sediment. The terms competence and capacity are used to describe the efficiency at which sediment can be transported. So the capacity is how much could it actually carry, and competence is really how much is it carrying. All of this really just comes back to talking about how do human interactions affect natural things, and how do rivers work in nature when humans don't try to control them. One of those things might be talking about flooding and the formation of new riverbeds like you see here.